Okay. So if you see the diagram which is on the board, there are two diagrams which I drawn. This is the first case I was saying that there is a relative sea level fall, what we call the base level fall. Now, what is base level fall? When you have a base level fall, then your base level from here it has come here. Okay, or we have said the 3 stages. So this part that is not in equilibrium. So the river system which was actually grading to this base level, that will now try to grade into this base level, and in the process it will cause incision, polyosol formation, coastal erosion. All these things it will. So actually what you are getting here, you will be getting an unconformity development here. Unconformity development. And this kind of unconformity, which is actually because of base level fall, that unconformity we call the type 1 unconformity. Type 1 unconformity, which is forming here, and that is associated with the channel incision, paleosol, and coastal erosion. Now we have come to this case. This is the case 2. And this is actually a product, you are getting a regression and what we call as forced regression. Forced regression. We call that forced regression, where you have an active base level fall. Now I am coming to the second case. What I am doing? I am not allowing any base level fall. Base level remains static or very slow rising. So either it is static or very slow rising. Very slow rising. Now what is happening? That you have a high sediment supply. High sediment supply. So if you have a high sediment supply, then what will happen? That the sediments, they will the high sediment supply, by which it will be supplied. It will be supplied by a fluvial system. So the fluvial system, they will form a large scale delta. So the fluvial system, it will carry the sediment and it will deposit into the basin in the formation of a delta. Now that delta may be grading and it is filling the basin. It is filling the basin. So in the process, what will have? If this is your original depositional substrate, this depositional substrate will raise here. Now it will come here because this surface has gone up because of the filling of the basin. So this is the depositional substrate here now. So at the top of it, I am getting an unconformity formation. Because this surface has now raised here and got from subaqueous, so it becomes subaerial. Subaqueous to subaqueous. We call this kind of unconformity as type 2 unconformity. Type 2 unconformity, which is actually the product of normal regression. Normal regression. But the definition of normal regression, I discussed earlier also, that where the base level is not falling, it is either static or slowly rising, but the sedimentation rate is so high that it is always influencing the rate of accommodation generation. So always the rate of sedimentation, it is getting higher than the rate of accommodation generation. So this is the fundamental difference between a normal regression and a forced regression. So what will be the character of this unconformity? There will be no channel erosion. No channel erosion. No channel erosion. What you may expect here? You may expect here pedogenesis. You may expect here pedogenesis. You may expect here, in case of carbonate, karstification. Karstification. All this, that is basically when the depositional substrate it comes here and it becomes sub-area. So you get the pedogenesis, acidification, but no channel incision. Mind it, channel incision will be associated with type 1 unconformity, which is associated with the forced regression. The channel incision I will not get in case of a type 2 unconformity, which is a normal regression, and there is no actual base level fall. There is no actual base level fall. So these are the two different regressions that I talked to you here. Is it okay? Is it okay or there is any confusion?
No, sir.
Okay. Now, once we have discussed that, what in the last class you might be remembering that I have drawn a curve which is the rate of base level change curve, and I on that rate of base level curve change curve I superimpose the sedimentation rate. If you can see the copy what we discussed in the last class, and then we divided the sinusoidal relative base level curve into different parts. We divided into normal regression, transgression, normal regression, forced regression. You may remember that diagram. Do you remember that diagram?
Yes, sir.
Yes, sir.
Yeah. So what I said that there are normal regression, forced regression, and transgression. These are the three stages what I said in that base level curve and the superimposition of sedimentation rate and the rate of base level change. So now how really we define the three cases? How really we define the three cases? Number one, suppose the first I discuss the forced regression. And I want to discuss that what will happen in the marine strata. Marine strata. Our main discussion of sequence stratigraphy is basically either in the transitional strata or marine strata. That I repeatedly discuss. That I will be discussing that how these things will happen. Please draw the three diagrams. And please let me know once it is drawn. Have you drawn?
Yes, sir.
Yes, sir.
Okay. So what is shown in these figures is to show you that how we actually get the stacking pattern, the stratal stacking pattern in the three different types of situation. Because in the when I plotted the base level curve and the sedimentation, I subdivided the sinusoidal base level curve into three parts. That is normal regression, course regression, and transgression. Now, what I am showing that in these three different conditions, though there will be a lot of variation in it, which is the more simplistic diagram. We will discuss lot of complication in it. Broadly, the three different things, that is the post regression, normal regression, and transgression. In the three different cases, how the stratal pattern that will differ, what actually is happening on the coastline, and how it will be reflected in the stratigraphic succession and the stratal pattern. Broad difference. I am talking about broad difference. The three different cases. First, post regression. What will happen? That the younger strata, they will be leaving the earlier or preceding strata exposed. So, a thecal line, it actually indicates the unconformity formation. By this thecal line, I am actually indicating that there will be unconformity formation. Okay, unconformity formation, and they are actually off stepping. They are stepping off stepping. माने steps are getting off. एक तो छोड़ के आगे जा रहा है, step के off stepping. But they are also in the lower part. In this part, they are down stepping. So it is a step, then this, so this. If this is arrow, this is arrow. So they are down stepping and off stepping. So because initially your accommodation was this, then your accommodation was this, then your accommodation was this, then your accommodation was this. So successively your accommodation is decreasing. Successively your accommodation is decreasing, and I am considering that the sedimentation is constant. Sedimentation मैं vary नहीं कर रहा हूँ. Only I am seeing the reflection of base level change. Sedimentation constant. Here in this diagram, sedimentation constant. I am seeing the reflection and what will be the result of different tendency of the base level change. Now, first one, the base level is successively going down, the accommodation decreasing, and you are getting the off-lap, the off-step, and down-step, and that is the typical stacking pattern. We will come into more complication in it afterwards. Now come on to the normal regression. Sedimentation constant. Now what will happen? Then this is 1, this is 2, this is 3. So successively your accommodation increasing, but increasing at a low rate. Increasing in low rate. Base level is not falling. Base level rising at a low rate. Low rate. So what you will be getting? You will be getting the upstepping. Yeah. In the proximal part, you will be getting upstepping, which are also referred to as aggradation. That means the strata will aggrade. Strata will aggrade. There will be the fluvial and the downstream fluvial aggradation. So strata will aggrade, and it will be also downstepping. So upstepping and downstepping, including the aggradation in the coastal part, that is the character of the normal regression. Character of normal regression. So what is the difference between forced and the normal regression? How I will be when I will be seeing the seismic transit or will be working in the outcrop field? We have to see that in one case there is a uplap and there is a downlap. Uplap and downlap, but here there is a aggradation or upstep and the downstep. So these are the fundamental difference. Now coming on to transgression, where the base level is rising. Base level rising at a fast rate. So what you will get? The base level is rising, and then you are getting the retreating beach, retreating coastline, retreating beach. So what you will get? Retreating beach, coastline, formation of coastal cliff. What I will expect here? Aggregating fluvial system or aggregating fluvial system. What I will expect here? These are the shore face wedges. Wedges. So, is it clear? Is it clear or any question in it? Hello.
Yes, sir.
It is clear. So you are understanding that what is the fundamental difference between forced regression, normal regression, and transgression. In forced regression, the accommodation is decreasing, and you are getting your strata will be leaving exposed the earlier strata, and the unconformity that will be forming in the which is a type 1 unconformity that you are getting, and you, there will be the upstep and the downstep. In case of normal regression, it is a base level is rising at a low rate, so there will be aggradation in the coastal part, and that will be associated with the downstepping in the marine part. So the downstepping and the aggradation, what we also refer to as the upstepping. So the upstepping and downstepping, these two together, that will form the normal regression. And what about the transgression? In transgression, the base level is rising at a faster rate, and that will be causing to the development of the retreating beach, retreating coastline, formation of coastal cliff. All these are basically where you are retreating the coastline, and that will be fast rate. It is retreating. So this is the fundamental difference between the three. Now, Okay. Now, once we have this idea, then we'll come to the real situation that when we have a relative sea level curve and how these different things that are subdivided, we will introduce you to the concept of system tract. Now we will discuss that what is system tract and how this forced regression, normal regression, transgression, they are related to the different system tract. That we will be discussing with respect to a relative sea level curve or relative base level curve. What we call the sea level curve or the base level. Base level. So relative sea level and base level curve. So suppose I start from here. I start from here. So this is the curve and I end my from here to here. You can start from any point, here to here. You can start from here to here. But I am starting it from here to here. And that I am making it a cycle. This is a complete cycle. This is a complete. You agree with me? This is a cycle.
Yes, sir. Yes, sir.
Yeah. Now, this cycle, I want to discuss that what are the different parts of this cycle. What are the? This is a total, say the relative sea level or relative base level curve, and it's one cycle. I am picking up one cycle. There will be similar cycle repeatedly. There can be similar cycle repeated. Now this cycle, so if I start from here, that here I am this is the relative base level curve. So the first part of this curve is that really the fall of the base level. This is the fall of base level. Fine? Fall of base level. Now this base level that will be falling, and this is the last point of base level fall. Fine. Then from here to here, this portion base level rise but at low rate. So if it is A, B, C, base level rise but at low rate. Then from C to D, yeah, okay, D, this is base level rise at a high rate. At a high rate. And then from here to here, this is E. This is the high base level. High base level. High base level with limited rise or fall. Then again you get the fall of base. So this stage again comes. So you understand that I am subdividing a relative base level curve into, this is one part that is AB, one part where there is a fall of base level, real fall of base level. Then BC, that is the very slow rise of base level. Then CD, high rate of base level levels. And D, high base level with very limited rise or fall. So I am just subdividing these four parts depending on the tendency of the curve. Tendency of the curve, I am subdividing the four parts. Fine. This part AB, that is called falling stage system tract. Falling stage systems tract. We will come to the discussion. What is the meaning of that and what happens in this? उसका detailed discussion करेंगे बाद में. Falling stage system tract, we call it FSST. FSST. Then come the BC. This we call low stand system tract. System tract. LST. LST. Then CD, we call it transgressive system tract. Transgressive system tract, that is TST. And D, we call it high stand system tract. System tract, that is HST. So what is a system tract? A system tract is a part of a, you can write the definition. A system tract is a part of a depositional sequence, which is marked by a definite stratal stacking tendency. Stratal stacking tendency. A definite stratal stacking tendency. And what is the stratal stacking tendency? That I have discussed just before this. That when you have a forced regression, what kind of stratal stacking? When you have a normal regression, what kind of stratal stacking? That I have already discussed. We will further discuss that what are the different types of that. That is a different step. Now, if I think it in terms of the base level curve, what I had drawn the class before the last class. So this becomes the forced regression when the base level is falling. This becomes normal regression when the base level is slightly rising. This becomes transgression, and this again becomes normal regression. Is it getting clear or not? If there is any confusion, just ask me. Hello?
Say it's okay.
So, if you have as I discussed in my base level curve that we subdivide the base level based on the post regression, translation and normal regression. And then when I superimpose that concept of post regression, normal regression, translation and again normal regression, when I superimpose that, I get the different tendency of the relative sea level curve and they are marked by the different statal stacking. So what is a system tract? If I then elaborate the system. A system tract is actually a genetically related depositional system. Genetically related depositional system which is connected to a definite tendency of the base level. That when the base level is falling, when the base level is slowly rising, base level is fast rising, base level. So in this different tendency of the base level, falling, slow rising, fast rising, the different genetically related depositional package, depositional environment that develops at that time of base level pattern, that is what is called the one system. So what is a system tract? That whatever the environments, whatever the depositional pattern, all they are genetically related because they all form when the base level is forming. Whatever is developing here, they are all genetically related because they are forming when the base level is slowly rising. So based on that, we subdivide this. This is what is called the revised exon systematics. Revised exon systematics. But this is what is called revised exon systematics. Now, what was the original exon systematics? This is called revised exon systematics. What was the original? Original exon proposal. Original exon, which was proposed by Van Wagner et al. 1987. Originally, when the sequence stratigraphy concept was proposed. When it was proposed, then when originally it was proposed, from here to here, they were not divided under two different system tracks. ये दो जो system track, this was not proposed in the original. What they said that from here to here, sorry, here, this is actually completely coming under low stand. Completely coming under low stand. So this divisioning that the low stand is, there are two parts. Because they were always saying that there is a regressional tendency. There was no concept of the post regression and normal regression. This concept was not there in the original exon systematics. So this concept of post regression and normal regression, this came after the original exon systematics that came in 1987. The concept of post regression and normal regression, this came with the work of the Hunt and Tucker. Hunt and Tucker in 1992. They actually seen that it is not the same what is happening when the base level is actively falling and base level is not actively falling. Instead, it is slowly rising. So you are seeing the regressive tendency, but the two regressions are not same. One is a product of the active base level fall, another is not the product of active base level fall. Instead, it is a product of slow rise of the base level. So the total regressive part, which was earlier, what people used to, the original exon systematics, it was divided into LST, TST, and HST. These three divisions were there in the original exon systematics. This LST was subsequently subdivided into FSST and LST based on post and normal regression. Forced and normal regression. Okay? Fine. Now, these system tracks, they have some bounding surfaces. Bounding surfaces. What are the bounding surfaces? Now, if this system track starts forming here and it ends its formation here, so it will be bounded by a surface which is called sequence stratigraphic surface. Suppose I mark it sequence stratigraphic surface 1. Now this ends here. This marks sequence stratigraphic surface 2. Now this system track ends here. This is SSS 3. This ends here. This is SSS 4. And this again is this. So there are different surfaces which are equally important as that of the system tract, because the system tracts are known by their bounding surfaces. Known by their bounding surfaces. And there are 1, 2, 3, 4. The four sequence stratigraphic surface that bound the system tracts. Bound system tracts. That bound the system tracts. What are those sequence stratigraphic surfaces? And what are those sequence stratigraphic surfaces which will basically bound this system tracts? The system tracks, they are basically bound by some surfaces. Now, what are the surfaces at the bottom and at the top of the different system? The falling state system tract, it will have the surface which will be flooding it, which will be flooding the falling state system tract. That is the regressive surface of marine erosion. It is also called basal surface of forced regression, or in the marine system you call it regressive surface of marine erosion. We will be discussing this in detail, that what is the character, how we identify in the stratigraphic section, how this surface is formed, what is the origin of these surfaces, what is the mechanism of formation of this surface, and how it is recognized in the field. That we will be discussing in detail in next class, not in today. But the thing you must know that a falling state system tract, it will be flowed by a surface which is called regressive surface of marine erosion, or it is called the basal surface of forced regression. The top surface of this is the correlative conformity. Correlative conformity. The low stand system tract, it will be bound by a correlative conformity at its base, and the maximum regressive surface MRS, that will be at the top of the low stand system tract. Maximum regressive surface. Some people also refer it as transgressive surface. Some people also, either it is maximum regressive surface or we call it transgressive surface. Then comes the TST. TST will be flowed by maximum regressive surface or transgressive surface, and it will be topped by the maximum flooding surface. Maximum flooding surface. We will discuss what is the character of maximum flooding surface, how we identify that in the outcrops, how we identify in the seismic section, in the subcrop, how we identify the well log, all everything we will discuss. And then from the maximum flooding again to this regressive surface of marine erosion, this portion which is again a normal regression, that is called the HST. So now you know that which surface is bounding which system tract. So any system tract boundary definition or any system tract documentation, not only it will be depending on the stratal stacking pattern and how the strata they are packed, but also it will be related to that what kind of surface is flooring it and topping it. So the floored surface which is flooring it and with the surface which is at the top, both will be equally important to qualify something as a particular system tract. Am I clear?
Yes, sir.
Okay. So, before I proceed further with the detailed discussion of the different system tracts and their pattern in a coastal setting, that how really the in the coastal setting the continental and the marine system, they will be combinedly respond to the different base level pattern. Let me today draw you a complete depositional sequence model. This diagram you will be getting in any internet. If you Google the a sequence stratigraphy model, this diagram will come. Now this is a combined, because I will be going to the discussion of the individual part. So before discussing into the individual part, I want to discuss with you the general model of a depositional sequence, which is topped by a type 1 sequence boundary, which is closed by a type 1 sequence boundary and is topped by type 2 sequence boundary. Type 1 sequence boundary and topped by type 2 sequence boundary. class. You please draw this diagram first. Today's class will be ending with the discussion of this diagram. Please let me know when the drawing is complete.
Done, sir.
Yeah. So this is a full scale. Full scale, I would say it is a full scale sequence model that is drawn here. That, as I have already discussed, that a sequence when we start with this. So if I start with this is the first fall of the base level. So the entire period there will be unconformity generation. So it is a successive fall. So fall is not a single event, but it is successively fall, successive fall, successive fall. And continuously the unconformity it is falling. So what is an unconformity? It is a synchronous surface or a diachronous surface. What is an unconformity? Is it a synchronous surface or a diachronous surface?
Diagram.
Hello?
Diachronous, sir.
Diachronous surface. So now you can easily identify that different time plane it is cutting across the unconformity surface. So a unconformity is a diachronous surface. And this diachronous surface unconformity that is forming in the shallow coastal part of the seafloor as the base level is falling. And this unconformity, this is actually the correlative. So what will happen when there is a type 1 unconformity formation, a base level fall, there will be channel incision. There will be channel incision. And this channel incision, what the sediment of the channel incision will do, that will be deposited at the base of slope in the form of submarine pan. Now this submarine pan and all these environments I have already discussed in the sedimentology course. So no repetition here. We will only discuss that what environment and what condition it is forming. Now you see the submarine pan at the base of the slope. When will it form? It will come from anywhere. No, it will form when there is a real sense base level fall. So when there is a real sense base level fall, the channel incision, that channel incision onto the shell, channel incision the coastal part, as well as the canyon formation on the continental slope, all these they will deposit the material at the base of slope in the form of submarine fan. Now, as long as the submarine fan is forming, so as long as the base level is falling, the submarine fan is forming. As long as the base level is falling, the incision was going on, submarine fan was forming. Now, when the base level with continuous fall, it has reached here. It has reached here. So that means the fall has ended. Now the fall has ended. So what is this surface at the end of the fall? As I have drawn in the last diagram, what is this surface? That is the correlative conformity. I said that the top of the force regression will be correlative conformity. So where the correlative conformity will come? It will come at the top of the force, the product of this. This product is the submarine fan, and its top will be the correlative conformity. Top will be the correlative conformity. Okay? Fine. After that, the base level is rising but at a slow rate. So what will form when the base level is rising at a, so what is happening? That the sedimentation, it is keeping pace, or it is actually overriding the rate of base level rise. So the normal regression that you get the low stand delta or low stand. So low stand delta or low stand wages. These are wages, these are delta. So low stand wages and low stand delta. So the delta will form, the wages will form, and those will be the low stand wages and low stand delta when there is a slow rise of the base level. So that slow rise of the base level, that will be connected to this formation of the low stand delta and the low stand. And what will be at the top of it? At the top of it will be maximum regression surface. So the regression is continuing. First forced regression, then normal regression. Forced regression, product is submarine fan. Normal regression, product is low stand delta, low stand wages. Above this will be the maximum regression surface. or if I talk about in terms of regression, it is the maximum. And after that, there is no regression. So that is the maximum regression. So if I talk about the regression, if I talk about the transgression, it is the onset of transgression. So the plane which marks the last regression, it is the same plane which marks the onset of transgression. So some people who actually talks about the regression, they mark it as a maximum regression surface. Those who are bothered about transgression, they mark it as a transgressive surface. So the transgressive surface and the maximum regressive surface that comes at the top of it. Above that is the PST. You can see the basis beds, they are retrograding. They are retrograding. Anywhere you will get a fining of succession. Fining of succession. So the basis bed is retrograding. It is the retrogradation. Basis bed migrating towards the land, and that is what is the typical character of the transgression. The top of transgression, that is what is maximum flooding surface. Maximum flooding surface. So this is the maximum flooding surface, which is the most regionally extensive surface that will bind the. So what will happen across this maximum flooding surface? Here you are getting the retrogradational or aggradational stacking that will be overlaid by the downlapping strata. So these are the HST. Above the MFS, you get the HST. So HST, again you have a delta that is developed. You have got a delta in the low stand, you will also get a delta in the mud. These two delta, the character of the delta and everything will be different. How it is different, we will be discussing. How we will be identifying a low stand delta and a high stand delta. What will be the character? What will be the character of the pluvial system that is supplying the delta? How the delta, nature of the delta, what kind of flow that will be operative in a low stand delta and high stand delta. All these are different. So you have another delta. So, but in terms of the strata, how you are getting a retrogradational, you are getting a gradational strata, and that will be overlain by a progradational strata, and that will be the downlapping strata. So the aggrading strata overlain by the downlapping strata, that is a typical character of the MFS. Above this, you are actually again in a normal regression, and there is another development of delta, which we call the high stand delta. The top of the high stand delta, that will be marked the type 2 sequence boundary, where there is no base level fall, but only the emergence. And then this is the end of the cycle. This will be followed by another base level fall. That can be another base level fall and the development of the next sequence. So successive sequences, they may be stacked. So because they are one sequence, this is the product from here to here. So this is the entire product. How we will be delineating this entire product? So you can develop the submarine band, the low stand delta, low stand wave, the estuary, the athletic fluvial system, and then you can have a high stand delta. This is the ideal model. I again repeat you, this is an ideal model, ideal sequence which may not be available everywhere, every time. So there are a lot of variation, but this is an ideal exon depositional sequence model. Am I clear? Or there is anything you want to know in this? You have actually this board teaching and this is nothing. You actually even now I do not understand sequence stratigraphy. I am telling you. When you go to field and try to do sequence stratigraphy, then you will understand that you do not know anything. So at least for passing the exam, if you can understand that what is being told, that is enough. Is there any question?
Excuse me, sir. Sir, I have a question. One question, sir.
Yeah, please.
Sir, can we call the system with a bounding the stratigraphy sequence stratigraphy surface as a which bounds the system track as a parasequence boundary?
No. Parasequence is completely different. This is nowhere related to parasequence. Parasequence definition that was different. I will come to that parasequence. And then the last 5 to 6 years, the entire concept of parasequence has been heavily criticized, and people really do not now write about parasequence. Parasequence concept is getting obsolete actually. Obsolete because there is a huge criticism of parasequence. Anyway, we will discuss parasequence. We will discuss the why parasequence has been defined, and then we will also discuss what is the pitfalls or shortcoming of the parasequence concept. I am not going to parasequence at all. I am only defining the system tract and the bounding surfaces of the system. Just itna hi bol rahe hain, that this is a system tract and there are bounding surfaces of the system. So there are different bounding surfaces. What will be the character of the bounding surfaces? How they are formed? We will be discussing in coming classes.
Okay, sir. Thank you.
Okay. So if there is, you can go through it and ask the question anytime. But if you have any question or if you don't have question, we'll call it a day.
Sir, one more question.
Yeah, please.
How we define the equilibrium profile as we have discussed it in the previous class?
Yeah, equilibrium
base
profile.
level.
Yes, equilibrium profile is a idealistic profile. Idealistic profile. Any equilibrium profile can be for anything. It can be an equilibrium profile for a fluvial system. It can be an equilibrium profile for a coastal system. It can be equilibrium profile for a wave equilibrium surface profile. So when I talk about equilibrium profile, that is not connotative to any particular environment. You understand? When
Yes,
we
sir.
call it a equilibrium profile, that in case of a fluvial system, I will come to the marine system. In case of a fluvial system, a equilibrium profile is that profile of a fluvial system where the fluvial system can carry sediment without any net erosion or net deposition. No net erosion, no net deposition. The sediment, what is coming, it is only transporting the sediment to the final sink. It is bringing to the source and supplying to the sink. Nothing deposited within the fluvial system, nor any new sediment generated within the fluvial system. That idealistic profile of a fluvial system is called its equilibrium. Okay?
Okay, sir.
You got it? So that is a fluvial equilibrium profile. Fluvial. Now, if I ask question, how long Ganges will be flowing? How long Brahmaputra will be flowing? Can you answer that question? How long the Ganges will be flowing?
No, sir.
Yes. That is the question. That suppose when Ganges started, you have any idea when Ganges started flowing?
No, sir.
Ganges, what is the main source of Ganges? It is the Himalayan glacier, isn't it? But Ganges also gets sediment because of precipitation and the groundwater flow. I am not going into that. But when you talk about Gangotri, when you talk about so the main source of Ganges, it starts from the Himalayan glacier. And that Himalayan glacier is basically part of the higher Himalaya. So before the higher Himalaya formed and before the glacier started forming, I do not believe that Ganges was flowing. So when did it form? It is in the late Miocene. The late Miocene, the largest the collision and the rise of higher Himalaya, Ganges must be started flowing after the rise of higher Himalaya and the formation of the glacier system. After that, the Ganges started. Is it okay with you, this explanation?
Yes, sir.
Yeah. So if I am giving you a logical because I was not there, nobody was there, nobody has seen that the Ganges is started flowing. So we are coming to a logical conclusion. We are going to a logical conclusion. Okay? Now, neither you can date anything in a Ganges sediment which can talk about that, yes, from this time it started flowing. There is no process, no mechanism, no system that can date the Ganges sediment and tell that this is the time Ganges started flowing. But then I have to go by a logical thinking, and logical thinking says that the formation of glacier which started with the formation of higher Himalaya, and then after that the Ganges system possibly started. Now, second question, how long Ganges will be flowing? How long it will continue flowing? Will it flow forever, or the Ganges will stop sometime in flowing? So now comes the second question. Now, as long, why a river flows? A river flows to attain its graded profile. River always flows to attain its graded profile. I always try to make a more comfortable life for me. I always want to go to sleep in my own bed. So everything it actually requires is comfortable situation. For Ganges, the equilibrium profile, but Ganges is flowing, it is carrying sediment, it is depositing, everything it is doing to achieve its equilibrium system. But it is not achieving because Himalaya is continuous. Once it is eroding, it is depositing and trying to achieve its equilibrium. By that time, there is a Himalaya is further rising because the continuous rise of Himalaya is going on. There are intrabasinal tectonics as well, which disturb the profile. So always the river tries to attain a graded profile, but it is every time and recurrently it is getting disturbed. And as long as it is going to be disturbed, then the Ganges will go on flowing if there is a supply from the glacier. If the glacier is totally melted away, Ganges will also become dry. So what they say, the glaciers are totally melting away. So if glacier melting away, total Ganges will be dry. Now see the problem. This is the fluvial graded system. Now what about the marine? In a marine, the wave, the current, they have an energy, and that energy will also try to make a wave equilibrium shortest profile. That is the equilibrium shortest profile for a prevailing wave current system. And any change in the equilibrium profile, wave will again try to make the profile in equilibrium. So all the system, whether fluvial, whether wave, everything tries that to make their profile equilibrium. We will discuss that effect of wave equilibrium and how it affects the sequence stratigraphy concept. We will discuss that also.
Okay, sir. Thank you, sir.
Okay. Any further question? Okay. So we'll continue with this in the next class with further lot of ramification of what we have already discussed. So there are a lot of ramification of that and how that basically controls our further thinking process about the sequence development pattern. Okay, thank you.
Thank you, sir.
Thank you, sir.